So we're starting on chapter 21, lesson 2, area of a parallelogram. We're going to start our geometry unit. So we just finished up decimals and we're going to move on to geometry. Our objective for today is to use a formula to find the area of parallelograms. So we're skipping lesson 1, but we're going to look at the example on page 454, which talks about Kimberly, who has designed a set for a play. The set will be in the shape of a parallelogram. And the base will be 30 feet, and its height will be 15 feet. Okay, so the base is 30 feet, and the height is 15 feet. I drew the height as a dotted line because it's not the height of the side of a parallelogram. It's the actual height of the parallelogram, which is always going to be a perpendicular line to the base. That's why I gave this little symbol here, okay, this little square looking thing, okay, to show that it is a perpendicular line. And a perpendicular line forms what degree angle, Ishika?
90 degrees.
90-degree angle. So it is a straight line perpendicular to the base. And we know that the base is 30 feet. Okay? So let's use the formula. The technical director needs to know the area of the set so she can mix enough paint. What is the area of the set? Because she wants to paint this. So remember, area, when you think of area, it is a 2D, two-dimensional area. Okay? So it's not 3D, it's a flat surface. So I always think of area as surface of something. And you're trying to cover the entire surface, okay? So if we wanted to paint this parallelogram and make sure all of it is covered in paint, that's what area is talking about, okay? So when you hear the word area, think of a surface and how you're going to cover that surface. So what is the formula that you should be using? Well, it's pretty, you guys might be familiar with it. It's area, A for area, equals base, B, times, multiplied by height, okay, to find the area. Pretty simple, okay? So as long as you know 2 of the 3 things, you're able to find out the missing variable, okay? So do we know what the area is? No. Do we know what the base is?
Yes.
Okay, and the base is?
30 feet.
30 feet, very good. So we replace the B and we put 30 in its place. Then we multiply that by the height, which is? 15. So instead of the H, we put the number 15. Okay? And we multiply that together. So this is pretty easy. If you think of just 15 times 3 is how much? 45, and then you just add a 0. Okay? So you get 450 feet squared. Okay? Why is it squared? Why do you need the little 2, or why do you need to write the label as square feet? Tom?
Because it's not really 450 feet wide or tall.
Very good. And why else do we need that square symbol in there? Jason?
Because if you represent one square in the whole parallelogram as 1 foot by 1 foot, then that's how many 1 foot feet it is.
Right.
In the square.
Exactly. That's how many squares can fit inside of this. How many cubic squares can fit inside of this parallelogram? 450 little centimeter cubic squares can fit inside of this area, right? So, feet, sorry. So when you guys do that, and you also think of, remember what I talked about, 2-dimensional, right? So you can think of 2D as in square foot 2, okay? 3D, the label will be a 3. You are only dealing with 2 dimensions, the height and the base, okay? And so we're multiplying 2 things together. And remember way back at the beginning of the year when you guys learned powers of 10 and you guys learned about exponents, right? The 2 is an exponent saying you're multiplying 2 numbers together, okay, to get the area. So you have 450 feet squared. So that's how much area that needs to be covered. So once you know the area, you can figure out how much paint you need to go out and buy and make sure it covers that area. Okay, so we have another parallelogram here, and the base is 7 inches, okay? And the height is measured outside of the parallelogram. The last example, the height was where? Inside, right? So sometimes you can measure, it's easier to measure the height on the outside, as you can see here, and I put my little square there to show that it's it's perpendicular to my base, and the height is 5.5 inches. Okay? So again, our formula is area equals base times height. Do we know the area?
No.
Do we know the base and the height?
Yes.
Okay, so we got to plug in those numbers. Okay? So we take area equals, what is base?
7.
7, very good. And what is height? 5.5, right? So now this is where your multiplication of fractions comes in handy, right? So you change 5.5 to what?
11 over 2.
Very good. 7 stays the same, or you can make it 7 over 1, and you make this 11 over 2, and then you multiply across. So 7 times 11 is over 2. How many times 2 go into 77? 38. Okay, 38.5, right? So, or since this is all in fraction form, we change 38.5 to 38.5 inches squared. Okay, so the area is 38.5 inches squared. So if you think about it, right, the number is quite large compared to what you see for the base and the height. And so remember what Jason said, right? Think about little tiny squares being placed inside of this parallelogram. How many of those inch squares would fit inside of there? That's what you're thinking of, okay? So look at page 455, top. Here we have the parallelogram. We have 10 meters here, 4 meters here, and 5 meters here. So there's 3 sets of numbers, okay? So in order to make this easier on myself, I always label next to the numbers what is what, okay? So do we know what the base is here? Yes, what number? Is it the 10, the 5, or the 4? 10, right? Okay, that's easy. We have the base, okay? Now we need to find the height. But there's 2 options. There's 5 meters, which is the length of this side here, and then there's 4 meters, which is the length of this perpendicular height, okay? So which of these 2 is the height? Which one is the height? Mark?
4 meters.
4 meters. How did you know that it was 4 meters?
Because usually the height is supposed to be straight, not diagonal. If it was diagonal, it would like shorten or widen, like the height, or like make it smaller or make it higher. So it would change the effect.
Right.
So if you do it straight, it's like positive and it's like exact, so you can see the exact number.
Exactly. And think about this. Say I was going to chop up my parallelogram right here. Okay? What shape is that? Triangle, right? And I took that triangle and I flipped it and I brought it inside of here. Would it fit?
Yes.
Yes, it would. So then now what shape is my parallelogram? A rectangle. It becomes a rectangle. A 10 by 4. Because what do we know about the area of a rectangle? What is the formula for area of a rectangle? Ashika?
A equal to L times W.
Right. A equals length times width. Right? So, and the width here is a straight line in a rectangle, right? So it's not a what line? A slanted or crooked line, right? It's a straight line. So that's where the parallelogram gets it from. Okay? Parallelogram is essentially a tilted rectangle, okay? But we don't want the tilted side length. We want the actual perpendicular 90-degree angle straight line length, okay? Because if you were going to chop off the ends and replace it, you would actually get a rectangle, okay? So area of a parallelogram, the b times h, the base times height, is the same thing as saying length times width, okay? So now that we know what is what, and we know that this is our height, we can plug in the numbers, correct? Yes. So now we take area equals, what is the base? 10. At times, what is the height? 4. And we get 40 meters squared. Don't forget the meters squared. Okay? Let's do one more. Okay, so this time, in this parallelogram, the height is inside or outside?
Inside.
Inside, yes. Okay? Remember, it can be inside or outside. And they have a little arrow that's pointing to it, which is 1.5 inches. Okay, and then on the bottom here, it's 2 inches, and on the side here, it is 2 inches. Okay, so again, the area of a parallelogram is equal to the base times height. Do we know what the base is? Yes, we do. What is the base?
2 inches.
2 inches, very good. And it's right here. And which one is the height?
1.5.
1.5. Remember, you're always looking for that straight up and down perpendicular to the base line, and it's 1.5. So this one is the height. Okay? So let's multiply these two numbers together. Area equals 2 times 1.5. Now, we just did a whole chapter on multiplying and dividing of decimals. So should you be able to do this? Yes. Okay, so take 1.5 times 2. Ignore the decimal. Bring in the decimal. And you get 3 what?
3 inches squared.
3 inches squared. Area equals 3 inches squared.